This is a demo for a preliminary version of NetTrails, a declarative platform for interactively querying network provenance in the distributed system. As a running example, we utilize the min-cost protocol, which computes the shortest path between all pairs of nodes. As we can see, this protocol is written in NDlog language and uses 3 rules. Here the protocol is running. The RapidNet visualizer shows a replay of the protocol execution. As we can see, we have link updates, namely the insertion and deletion of links. RapidNet visualizer is able to capture these updates. With the topology updates, nodes communicate with their neighbors to recalculate the best paths. The bandwidth utilization is shown on a graph on the left-hand side of RapidNet visualizer. At any time, we can pause the RapidNet visualizer and it will show the system-wide provenance in the Provenance visualizer on the left-hand side of the screen. We can navigate the Provenance visualizer by clicking or dragging, and the transitions, as you will see later on, are fairly smooth. For example, we can look at the table best path cost and explore a derivation of a particular tuple. For instance here, if you hover over a tuple node in the Provenance graph, it will show the details of that node. It gives information such as where the node is located and the number of children that that particular node has in the graph. We can further explore the provenance of that tuple using the interactive interface. In this example, the derivation of the best path cost tuple depends on a path cost tuple, which is further derived from another best path cost tuple. We can continue to explore the derivation until we arrive at the base tuples. In the case of the min-cost protocol, the base tuples are the direct links between tuples. We can also select individual nodes in RapidNet visualizer. Upon clicking on a node, you are able to see the provenance table for that node. If you double-click on individual entries in the table, it will put the selected tuple in the center of Provenance visualizer. If you double-click on another entry in the table, the Provenance visualizer will change the focus accordingly. Another feature that we added are the step buttons, which allow the user to step forward and backwards at 5 millisecond intervals. As the user steps through the RapidNet visualizer, the Provenance visualizer updates accordingly, showing the changes in the system-wide provenance with respect to time. For instance, currently we are showing the provenance graph for time 70. Instead of limiting users to only exploring the provenance graph through the Provenance visualizer, we also allow users to issue interactive queries. As shown here, we query the provenance for best path cost from node 3 to node 5 with cost 2. Upon issuing the query, we are able to view the steps taken in the recursive distributed query. Although currently the steps are displayed in the pop-up window, in the complete version, the progressive steps will be instead visualized in the Provenance visualizer. So here we'll allow the RapidNet visualizer to continue playing the protocol execution as we approach the end of the demo.